Have you ever wondered who teaches a machine to write a poem or paint a sunset? The answer often lies with a generative AI researcher. This role is one of the newest and most fascinating frontiers in technology. It sits at the intersection of computer science, mathematics, and pure creativity. They build and refine AI models that generate text, images, music, even computer code. Not just programmers, digital sculptors, shaping vast data into tools that augment human creativity. Their work is changing how we create and interact with information. At the core are models you know: GPT for text, DAL, EE for images, Stable Diffusion for visual art. Their job: make models more intelligent, more accurate, and more useful. They are the quiet architects behind a new creative revolution. A typical day is a blend of theory and hands-on application. The field moves at breakneck pace. New breakthroughs land almost daily. To stay sharp, researchers absorb findings, understand new architectures, and learn novel training techniques. Then it shifts to code, primarily Python, to design, build, and train models. The work is meticulous and planned. Selecting and preparing massive datasets is crucial. Quality and diversity determine what the model learns. Testing goes beyond error-free code. Answer questions accurately, summarize coherently, maintain personality. For images, follow complex prompts, match artistic styles. Refinement, fine-tuning, means small, deliberate changes to parameters and data. It is an iterative loop: tweaking, retesting, analyzing. Demos translate abstract progress into tangible examples the whole team can grasp. 3 prominent tools: GPT, DAL-E, and Stable Diffusion. Each specializes: language, text-to-image, and flexible diffusion-based visual generation. GPT powers chatbots and writing assistants, from emails to complex code, guided by your prompt. Researchers sharpen fluency, factuality, and nuanced instruction following. Type a phrase, and DAL-E conjures the visual version of the idea. Work focuses on prompt interpretation and photorealistic or artistic quality. Stable Diffusion is open and flexible, fine-tuned for specific styles, like a game studio's concept art. Researchers experiment with composition control, style, and character consistency. All these models learn patterns from vast data to create something new. Great researchers understand each tool and how to combine them for new applications. In media, AI summarizes lengthy government reports and earnings calls, surfacing key information fast. Drafting standard pieces frees reporters for deeper investigative work. Entertainment teams generate concept art for characters and environments from sketches and descriptions. AI helps brainstorm plot and dialogue, augmenting, not replacing, creativity. Marketers spin up copy variants in minutes and A/B test at scale. Custom visuals accelerate agile, data-driven campaigns. Developers use AI assistants to suggest code, fix bugs, and explain complex logic, like a 24/7 expert pair. This speeds development and helps newcomers ramp up quickly. AI is accelerating other industries and its own creation. A generative AI researcher rarely works alone. PMs define problems, set goals, and prioritize features. Designers craft the interface, user journey, and feedback loops. If 3 images are generated, the designer decides how to present choice. Researchers build prototypes. Engineers make them robust and scalable. Data teams ensure quality, suitability, and coverage. Regular reviews and feedback ensure the product is useful and well-built. The result: a responsible AI product that solves real problems. Beyond technical challenges lies ethical responsibility, proactively identifying and mitigating bias. Models learn from data. If it reflects societal bias, the model can amplify it. For example, training on historical text can skew job-gender associations. Researchers test across diverse prompts and work to correct issues. Generative AI can create convincing misinformation, fraud, or harmful material. Safeguards include filters, moderation techniques, and safety protocols. The balance: restrict harmful use without stifling expression. Teams question consent and provenance. Was art, text, or code used with permission? Responsible datasets and techniques reduce memorization and copyright risks. Transparency, invisible watermarks, and detectable linguistic patterns. Clear labeling combats misinformation and builds trust. Success blends math, statistics, calculus, linear algebra, with strong programming in Python. Libraries like PyTorch and TensorFlow form the building blocks. Creativity and communication matter. Designing experiments and explaining complex ideas simply. Paths vary. Graduate study or self-taught. Build a portfolio. Fine-tune models, ship prototypes, contribute OSS. Demand is surging across tech companies, startups, and academia. This work builds systems that create and shapes how we produce and interact with content. Written by Benedict Evans.